There are angles that are considered special in rectangular coordinate system, especially in dealing with trig functions. And these are the quadrantal angles, the 30 degrees, the 45 degrees, and the 60 degrees angles. First are quadrantal angles. Quadrantal angles are angles with their terminal side lying along a coordinate axis. So these angles are integer multiples of 90 degrees or pi over 2. So you can have angles that lies in here, which is 90 degrees or pi over 2, or an angle that is clockwise, okay, which is negative 180 degrees or negative pi. These angles are examples of quadrantal angles. So in each case, take note that r, which is square root of a squared plus b squared, is equal to 1. So that's a positive number. So let's now find the values of the trig functions of quadrantal angles. However, we just have to take samples, but you can complete all the trig functions on quadrantal angles. Take note, guys, when we say quadrantal angles, we are not just dealing about the 0 degrees or 360 degrees here, or the 90 degrees here, or the 180 degrees here, or the 270 degrees here. We are also dealing with their coterminals, okay? If the rotation is more than 1 or more than 2, and so on and so forth. So long the terminal side lies on the coordinate axis, then that angle is quadrantal angle, whether it's greater than 360 degrees or less than 360 degrees, which is 90, 180, and 270 degrees. So let's have an example here. Find sine 90 degrees. Find cos pi. Find tan negative 2 pi. And find cotangent negative 180 degrees. So how do we solve this one? First is the for the sine 90 degrees. So where is 90 degrees located? If we are going to draw the rectangular coordinate system, it's here. So this is 90 degrees. And take note that our point AB there is 0, 1. Okay? And again, remember that R is always 1. And that's a positive number. And now the sine 90 degrees, which is b over r. Take note, guys, sine is b over r, as we have defined in a previous lesson. And b here is 1, and our r is 1. So therefore our sine 90 degrees is 1. Okay. Now if you want also to find the cosine 90 degrees, to find the tangent 90 degrees, cotangent, secant, and cosecant 90 degrees, then you can just use the definition and use the values of a, which is 0, b, which is 1, and r equals 1. So for number 2, we have the cosine pi. So pi again is 180 degrees. If we locate that one in the rectangular coordinate system, this is our angle, and that is pi. So here in this point here, our AB is negative 1, 0. So therefore our A is negative 1, our B is 0, and our R is 1. So therefore cos pi, which is A over R, it's negative 1 over 1, so that's negative 1. Next, for the tangent, negative 2 pi. Okay, so negative 2 pi, that's negative 360 degrees. So the angle is this one. Okay, the direction is clockwise, so that angle there is negative 2 pi. So in this point, our AB is 1, 0. So A is 1, our B is 0, and our R is 1. So therefore, our tan negative 2 pi, which is B over A, and B is 0 and A is 1, so therefore our tan is 0. For number 4, we have cotangent negative 180 degrees. So again, if we draw the rectangular coordinate system, negative 180 degrees is here. Okay, and this point here, the AB, is A is negative 1, B is 0, so therefore A is negative 1, B is 0, and R equals 1. So cotangent negative 180 degrees is A over B, and A is negative 1 and B is 0, and therefore this is undefined. Okay, so again guys, here you can also find the other trig functions of 90 degrees aside from sine. Also here, you can also find sine pi, tangent pi, and the other trig functions. Same with the negative 2 pi and negative 180 degrees. So these are just samples guys in finding the values of the trig functions if the terminal side or if the angle is a quadrantal angle. Next is for the 30 degrees, 45 degrees, and 60 degrees angles. First is for 45 degree angle. Consider this triangle. Suppose this triangle is an isosceles triangle, so meaning two sides are equal. Suppose these are the two sides that are equal, and the other side is the hypotenuse. Since this triangle is an isosceles triangle, and this is a 90-degree triangle, therefore this angle here is 45 degrees and this one is also 45 degrees, since the sum of the three angles in triangle is 180 degrees. Now suppose this side here is 1, therefore this is also 1. Okay, and we call this side as A, and this is B, and this is C. So how do we solve C? Again, C is equal to square root of A squared plus B squared using the Pythagorean principle. So therefore, our A is 1 and our B is also 1. So this is square root of 2. Therefore, this is square root of 2. Therefore, C is square root of 2. Now from here, we can have already the exact values of the 6 trig functions, which is sine 45 degrees. Take note that sine is opposite side over the hypotenuse and the opposite side of the 45 degrees, whether you consider this one or this one, the opposite is 1 and the hypotenuse is square root of 2, or after rationalizing, that is square root of 2 over 2. For the cos 45 degrees, we have the adjacent side over the hypotenuse, and the adjacent side is 1 and the hypotenuse is square root of 2. So this is square root of 2 over 2 after rationalizing. Now for the tan 45 degrees, we have opposite over the adjacent side, and the opposite side is 1 and the adjacent side is 1. So tan 45 degrees is 1. Also, the reciprocals of these functions are the cosecant 45 degrees, which is the hypotenuse over the opposite side. So that's square root of 2 over 1, and that's square root of 2. Also, for the secant 45 degrees, this is hypotenuse over the adjacent side. That's square root of 2 over 1, that's square root of 2. Now, for the cotangent 45, that's adjacent side over the opposite side, which is 1 over 1 equals 1. So these are now the exact values of the 6 trig functions if our angle is 45 degrees. So actually, this image here, this triangle here, can be generalized, because in the real world, this side here is not always 1. This side here is not always 1. So we can generalize that one, which is assuming this is equal to this one. Now, if this is A, and this is B, and this is C, since the two sides are equal, meaning A is just equal to B. So how do we compute now C? So B here is just equivalent to A. So how do we compute C? C is square root of A squared plus B squared. Okay? And B squared is just A squared. A squared plus A squared. So that's square root of 2A squared, which is A square root of 2. So this one here is A square root of 2. So all the sides here are expressed in terms of A. This is A. The B here is just equivalent to A. And the C here is A times square root of 2. So that is the general form of the triangle, of the right triangle, where the two sides are equal and each angle of the other angles aside from the 90 degrees is 45 degrees. So for the 30 degrees and 60 degrees, we can do it simultaneously, since we can just produce them in one triangle. Suppose we have this triangle here. Suppose this triangle is equilateral, so meaning the three sides are equal. Now, since the three sides are equal, the three angles also are equal. Now, since the sum of the angles in a triangle is 180 degrees, so each angle here is 60 degrees. Using this triangle here, can we already find the values of the 6 trig functions? The answer is no. Why? Our 6 trig functions are defined on the right triangle. So what we can do here to produce a right triangle is we will find a way so that this equilateral triangle here will have a right triangle. And we can do that if we cut this triangle with that side, so that what will happen, this becomes this triangle here and also the other half, assuming that my drawing is correct. So if this is 60 degrees, this angle here becomes 30 degrees, and this is 90. Okay, this is 30 degrees, this is 60 degrees, and this is 90 degrees. Now, if this side here is 2, since the three sides in the equilateral triangle are the same, So this is also 2 and this is 2. Meaning, this side here is 1. This side here is 2. Okay? And this side here is question mark. We do not know yet that side. Take note that in this new image, after having this side here, we can consider that as A, and this side here as the side hypotenuse, which is C, and what is lacking here is side B. So how do we compute side B? Again, the Pythagorean principle is C squared equals A squared plus B squared. And take note, the B is unknown. Therefore, we can just solve for B by transforming this equation using the addition property of equality. So that's C squared minus A squared equals B squared, or square root of C squared minus A squared equals B. Now, what is our C and what is our A? From here, C is 2 and A is 1. So therefore, our B is square root of 2 squared minus 1 squared. So that's square root of 4 minus 1 equals square root of 3. Okay, so now we have already the A, which is 1, the B, which is square root of 3, and the C, which is 2. So how do we find now the exact values of the 6 trig functions? First, for the 30 degrees. Okay? So for the 30 degrees, sine 30 degrees. Again, sine 30 degrees is opposite over hypotenuse. And what is the opposite side of this? Is our 30 degrees here. What is the opposite side is 1 and hypotenuse is 2. So sine 30 degrees is 1/2. Also, for the cosine 30 degrees, that's adjacent over hypotenuse, and the adjacent side is B, and that is square root of 3 over 2. For the tan 30 degrees is opposite over adjacent. So the opposite is 1 and the adjacent side is square root of 3. After rationalizing, that is square root of 3 over 3. Now for the cosecant 30 degrees, that's hypotenuse over the opposite side. That's 2 over 1 equals 2. For the secant 30 degrees equals hypotenuse over the adjacent side, and that is 2 over square root of 3. After rationalizing, that's 2 square root of 3 over 3. And for the cotangent 30 degrees, that's adjacent side over that's adjacent side over the opposite, and that is square root of 3 over 1, or that's simply square root of 3. For the again, for the 30 degrees, these are the exact values of the 6 trig functions. Now for the 60 degrees, we have sine 60 degrees, which is again opposite over the hypotenuse, and in this triangle here, this is our angle already, and the opposite side is the B, and B is our square root, and B is square root of 3, and the hypotenuse is 2. Also, for the cosine 60 degrees, that's adjacent over the hypotenuse. The adjacent side of 60 is 1, and the hypotenuse is 2. Also, for the tangent 60 degrees, that's opposite over adjacent, and the opposite side is square root of 3, and the adjacent side is 1, or this is square root of 3. For the cosecant 60 degrees, that's hypotenuse over the opposite, and that is 2 over square root of 3. And then rationalize, that's 2 square root of 3 over 3. For the secant, 60 degrees, that's hypotenuse over the adjacent side, that's 2 over 1, or that's simply 2. For the cotangent, 60 degrees, that is adjacent side over the opposite, so that's 1 over square root of 3, or that's square root of 3 over 3. So these are also the 6 values of the 6 trig functions for 60-degree angle. Okay, this also, again, the 30 degrees is pi over 6, and the 60 degrees is pi over 3. Also, the 45 degrees is pi over 4. If you are not comfortable using degrees as your angle, you can use pi, because degrees have correspondence in pi radian based from our previous lesson. Now, if we are going to generalize this one, we can have, we can have, this is 90, this is 60, and this is 30 degrees. Note that if this side is A, the C here is 2A, and the B, if we compute for the B is square root of C squared minus A squared, and our C squared is 2A squared minus A squared, so that's square root of 4A squared minus A squared, that is simply 3A squared, and that is A square root of 3. So the B here is A square root of 3. This is the generalized form. Take note, guys, that all the sides here are expressed in terms of A. The same as we did for 45 degrees. Okay, we express all the sides in terms of A in the generalized form. Now, since we already have values of the 6 trig functions for 30 degrees, 60 degrees, and 45 degrees, and also the concept of the reference angles and the reference triangles to find the exact values, we can use these values here and the definition for the other quadrants, or for the angles in the other quadrants that are multiples of 30 degrees, 60 degrees, and 45 degrees. For example, suppose our theta is 150 degrees, and find the values of the 6 trig functions for the angle 150 degrees. So what we're going to do here is locate first in which quadrant the terminal side of this angle lies, and then compute for the reference angle. Okay, so if this is the rectangular coordinate system, where is 150 degrees located? In the second quadrant. Okay, so this is theta, which is 150 degrees, and this one here, which is our reference angle. Again, how do we compute the reference angle in the second quadrant? That's 180 degrees minus theta, so that's 180 degrees minus 150 degrees, and 180 minus 150 is 30 degrees. Okay, now what are the exact values of the other 6 trig functions? Note that sine 30 degrees is 1/2. So therefore, this sine 150 degrees here is 1/2. But is it positive or negative? Take note also from our previous lesson of this simple concept here, the S, the T, and the C. Now, in the second quadrant, is sine positive or negative? The answer is positive from here. So therefore, sine 150 degrees is 1/2. Next is cos 30 degrees. What is cos 30 degrees again? From here, cosine 30 degrees is square root of 3 over 2. So that's square root of 3 over 2. So therefore, this cosine 150 degrees here is square root of 3 over 2. But what is the sign of cosine in the second quadrant? It's negative. Okay, cosine in the second quadrant is negative. So therefore, this is negative. Okay. Then the tangent 30 degrees is square root of 3 over 3. Square root of 3 over 3. So therefore, the tangent 150 degrees is square root of 3 over 3. And in the second quadrant, tangent is negative. Now, continue. The cosecant 30 degrees is 2. And therefore, cosecant 150 degrees is also 2. Now, cosecant is positive in the second quadrant, so that remains 2. Now, for the secant 30 degrees, that is 2 square root of 3 over 3. Is it correct? Secant, yeah, 2 square root of 3 over 3. So, therefore, our secant 150 degrees is 2 square root of 3 over 3. And then, secant in the second quadrant is negative. So, this is negative here. Okay? Now, for the sixth, which is cotangent 30 degrees, the cotangent 30 degrees is square root of 3. Is it correct? Yeah, that's square root of 3. So, therefore, our cotangent 150 degrees is square root of 3. But cotangent in the second quadrant from here, it's negative. So, these are the values of the 6 trig functions if the angle is 150 degrees. Now, if you don't want to find the values using this concept here, using these values here, you can just create the reference triangle and then use the side for the A, the B, and the C. Okay, this point here is AB. Okay, so you can just have the values of the 150 degrees. Okay, now if you don't want this one, then you can use what we have just done here, which is locating the values of the angles that is equivalent to our reference angle, and then copy the values, then locate the signs whether they are positive or negative using this concept. So we can have this exercise set. So try to find the exact values of this following using the appropriate reference triangles, and then applying the definition of the 6 trig functions and the special angles, the exact values of the 6 trig functions using the special angles, the 30 degrees, the 45 degrees, and the 60 degrees.